It can be hard to believe that our planet isn't permanent. That not only did the wider universe exist for more than 9 billion years before the Sun, the Earth, and the rest of the solar system, but that the universe will also continue long after our home is no more. But how exactly is the inevitable death of Earth going to unfold? Scientists may have just enjoyed a front-row seat to the preview. This is Unveiled, and today we're answering the extraordinary question, did scientists just discover how the Earth will end?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
In 2023, a years-long research effort finally concluded, and a team of scientists published a paper in the journal Nature announcing that, for the first time, we'd been able to observe what happens when a star eats a planet. Previously, while we were aware that this occurs regularly, we'd never actually been able to witness it firsthand. A major cosmological event, but it was one that had still been shrouded in mystery. And interestingly, in the 2023 study, scientists at first weren't even looking for what they eventually found. The research began as a search for binary star systems in particular, where two stars orbit each other harmoniously, for the most part. So how did that unveil such a dramatic and violent event as planet-by-star consumption? Sometimes the stars in a binary system move too close toward each other, and one will start to siphon off and absorb the stellar material of the other. The two might then collide and merge completely into one even bigger star. And when this happens, large amounts of light are unsurprisingly released, meaning that we should, in theory and under the right conditions, be able to see such an event from Earth. In practice, however, it's simply been too difficult to find these events in the first place, seeing as there's only an estimated 1 per 10,000 years per star cluster in a galaxy. But then again, there are many more galaxies out there, and many of them are visible to us, which is why, in fact, in 2017, such a merger of two neutron stars was actually observed. Although, in that case, it was thanks to the detection of gravitational waves, rather than the burst of blinding light that must have also accompanied it. All to say, though, that even star collisions are very hard to chance upon. But back to the 2023 paper. Once again, the research behind it was centered on searching for large, telltale instances of light in the cosmos. And in 2020, one particular light burst was observed, leading to a rush to try and parse what had happened. But researchers soon realized that the amount of light was much too small to be representative of another star-to-star collision. So what made it if not that? It took a few years and a lot of sifting through endless data from multiple sources, but eventually, scientists concluded that what they'd witnessed in 2020 was actually the very final moments in the life of a massive planet. A massive planet that had met its star and disappeared forever. And science, for the first time, had captured that very moment. The planet in question is, or was, an estimated 10 times more massive than Jupiter is, the biggest planet in our solar system, making it an extraordinarily large world, which is one reason why it registered on our earthly tech at all. But no matter the size and mass it once was, it disappeared very quickly. Again, so quickly that it took researchers literally years to work out what had actually happened in those moments. To the casual onlooker, the end of this apparently monster planet might well have looked like nothing more than a brief and flickering glitch within just a tiny speck of space. The star in question, the one that had just killed its one-time satellite, is estimated to be roughly 12,000 light-years away from us inside the Milky Way. The entire process of that star gaining luminosity and drawing the planet in, as a prelude to the planet-devouring act itself, described as an optical outburst, lasted for around 13 months total. The final peak outburst then went on for some 10 days. The star, which hasn't been named beyond its classification as ZTF SLRN 2020, isn't entirely alien to us though. In fact, it's not so different from our own star, the Sun. It's on its way to becoming a red giant, although still at an early stage toward that. But, as is now widely known, this is exactly what will eventually happen to our Sun as well. The fate of that now dead planet will be the fate of us, too. A red giant is what you get when a low-mass star begins to die. It indicates that that star has run out of hydrogen in its core and can no longer fuse that hydrogen into heavier elements. Hydrogen on the exterior is fused instead, which makes the star much bigger as it expands. On average, therefore, a red giant has a radius, that being the distance from the star's center to its outer shell, around 200 times bigger than the radius of the Sun right now. This expanded shell is then what's called an envelope, and it's the growing envelope that hungrily destroys anything that gets in its way, like the massive planet in this particular case. That red giant envelope is hot, huge, and it will burn without mercy whatever it touches. And again, this is the fate that awaits Earth someday, when the Sun, too, runs out of hydrogen. For the recently lost planet, and for us in the future, this period of ruthless expansion will last for millions of years, until eventually the envelope will have dissipated completely. What then remains is a white dwarf, the dead core of the star that once was, which isn't fusing any elements, but is still extremely hot. White dwarfs will, in theory, eventually cool down and fade so much that they become black dwarfs. But this process is thought to take such a long time that no black dwarf stars exist yet in the universe, and black dwarfs are therefore still theoretical. Unfortunately, since the process for a plain old red giant to become a white dwarf takes so long on its own, we're almost certainly not going to be able to see it play out to the end, even with this distant planet-eating star that we have at least registered. Unless, of course, humanity does end up finding a way to live for millions of years from now, and so can keep an eye on it. But nevertheless, it's still a star much farther along in its lifespan than our Sun is, so it will still be useful to observe. And indeed, the researchers tracking it are excited, because this distant star does provide at least a glimpse of what our Sun will be like when it begins to die. We know now, for example, that when the envelope does eventually reach Earth, it perhaps won't be an instantaneous end for our planet, but will instead be a days-long, hellish event. Luckily, what we are confident about, and have been for a while, is that it isn't going to happen to us for about 5 billion years or so, with the first truly intolerable living conditions not arriving on Earth until around 1 billion years from now. But the solar system isn't only ours. There are other planets, and some that are closer to the Sun. So exactly how much of the solar system might be consumed? Given, again, that average radius of a red giant shell, it's predicted that the Sun's envelope will likely stretch for about 86 million miles in every direction. But of course, the average isn't the only number that matters here, since it will only get bigger and bigger. And at its biggest, the red giant Sun is probably going to be nearer to 185 million, perhaps 200 million miles across. Considering that the Earth is, on average, 93 million miles away from the Sun, this is obviously pretty bad news for us. We sit right in the middle of that maximum distance, and it's definitely bad news for Mercury and Venus. Jupiter, on the other hand, is 480 miles away, and so it would hopefully survive, as will all of the other outer planets. Jupiter would then settle down to become the new Mercury to some degree, the now closest planet to our star, unless Mars escapes too by the skin of its teeth. But what about us, humankind? If humans are still alive by this point, which is a pretty big if, then we'll hopefully have already mastered the technology needed to survive this cataclysm too. Perhaps the most obvious route to species safety would be by setting up human colonies on the moons of the outer planets. Then we might want to make it all the way out to Saturn or even further, just to be on the safe side. And on the face of it, there are a few options for us. Europa in the Jovian system, Titan orbiting Saturn, or even Triton, Neptune's largest moon, and potentially a former dwarf planet that was once captured by the ice giant. But while we might be able to run, we wouldn't be able to hide from the existential problems forever. They will only return, but in different forms. Significantly, when the red giant envelope does dissipate, the white dwarf that's left behind won't then be as hot or as luminous as a living star. It won't ever again provide the equivalent energy that our vibrant present-day Sun ever did. So what then? What would your solution be? Perhaps we could build ourselves out of trouble by constructing new and artificial planets to orbit close enough to the white dwarf for safety. Or maybe we would need to have fled the solar system long before to stand any chance of continued longevity. Let us know your plan of action in the comments. For now, science has known for a long time that the Sun is going to someday devour the Earth. But only now have we finally been able to witness what this might actually look like when it does happen a few billion years from now. And that's why scientists did just discover how the Earth will end.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.